Hey guys, let's do lesson 6.10. Your learning target today is I will be able to identify equivalent expressions. So we're looking for equal expressions. Think about it. Are the expressions 12 plus 9 plus w and w plus 12 plus 9 equivalent? Prove it and explain how you know. Go ahead and pause the video and work out your think about it on your own, please. All right, guys, hopefully you worked out your problem. Let's go ahead and get started. So, I know because of the commutative property that I can move the addends around and it won't change my sum. So 12 plus 9 plus w is the same thing as w plus 12 plus 9. Okay, and that's the commutative property that tells us that's okay. Okay, there's another way that we could have done this. Okay, we also could have applied the commutative property, but this time instead of having 19 and 12, we're going to have, well, what's 19 plus 12? We're going to have 21 plus w. And then on the right-hand side, it's w plus 21, which still, according to the commutative property, we are allowed to move the addends around and it doesn't change our answer. Okay? The last thing we could have tried is we could have tried some substitution. So we could pick a number to exchange for w, to substitute for w, and then prove that it was correct. So let's try that one. Let's let w equal 3. Okay, so let's go ahead and plug it in. I'll plug it into the very first one. So we'll do 12 plus 9 plus w, which is 3, is the same thing as 3 plus 12 plus 9. Okay, so go ahead and simplify the left-hand side. We have just addition problems, but we have multiples, so we have to do them in order from left to right. So I do have to do 12 plus 9 first. Okay, 12 plus 9 we know is 21. Then we got to add 3. Okay, so 21 plus 3 gives us 24. Okay, now on the right-hand side, we got to start with 3 plus 12. 3 plus 12 gives us 15, and then we got to add 9. Okay, 15 plus 9 gives us 24. Okay, so there were two major different methods that we used. We used the commutative property, and we also used substitution, where we substituted in a value for our variable. Okay, and we proved it right there because 24 is equal to 24. So we didn't just prove it from a law, we actually proved it by putting a value into that expression. Okay guys, let's move on to test the conjecture. So the conjecture that we're going to test is algebraic expressions are equivalent if they can be evaluated to the same value. So let's start with test the conjecture number 1. It said, is the following equation true? 4m plus 12 equals 4 times the sum of m plus 3. So since our conjecture is talking about finding out if our expressions are equivalent if they end up having the same value, we're going to use substitution. Okay, we are going to let m equal 5, and then we're going to plug 5 in for our number sentence. Okay, so I'm going to solve the left-hand side over here. We have 4m plus 12, and then we have on the other side 4 times the sum of m plus 3. Okay, so let's plug in 5 for m. Again, I always want to put it inside parentheses, plus 12. Okay, we got to do with 4 times 5 first, because that's multiplication is higher on the order of operations than addition. 4 times 5 is 20. Bring down that 12. Okay, and then we have to just add 20 plus 12. 20 plus 12 gives us 32. All right, so let's start with the right side of our equation. Plug in 5 for m this time. 5 plus 3. And I didn't put my 5 in parentheses this time because unlike before, I didn't have a number right next to it. So like on this side, I could have confused the numbers for 45 and not 4 times 5. Okay, so let's go ahead and solve. We got to solve what's inside parentheses first. 5 plus 3 gives us 8. We bring down our 4. Now we have to do the multiplication, and 4 times 8 is 32. So if you check, we did get the same value on both sides of our expression. So these expressions are equivalent. So let's go ahead and write that out. Yes, they are equivalent. And we know this again because we plugged in our value of 5 for the variable and we got the same answer on both sides. All right, let's move on to test the conjecture number 2. Miss Joseph wrote the expression below on her chalkboard for her class. She asked the students to write an equivalent expression. So it looks like we have the x plus 2.1, so we got to add that sum first, and then we add w. Here is what the students wrote. Chanel wrote 2.1x plus w. James wrote x plus the sum of 2.1 and w. And Christian wrote 2.1 times x times w. So which, if any, of the 3 students wrote an expression that is equivalent to Miss Peterson's expression? So again, we are going to use substitution. So in this case, let's let x equal 1, and we have a second variable this time, so we have to pick a value for w as well. So let's pick 2. Okay, now we have to substitute these values in for 3 different expressions. We have Chanel. I don't know what that is. Chanel, who says 2.1x plus w. We have James, who says x plus the sum of 2.1 and w. And we have Christian, who's saying 2.1 w, xw. Not that it matters, right? Because of commutative property. So let's go ahead and plug in our variables and solve. So we have 2.1, okay, times, I didn't even change the color, times 1, we're using 1 for x, plus w, we're using 2 for w. Okay, so we have multiplication and addition. We have to do the multiplication first. So 2.1 times 1 gives us 2.1. Bring down that 2. Now we add for the last one. We got 2.1 plus 2, and that gives us an answer of 4.1. Okay, let's try James's. Okay, we're going to plug in 1 for x, so 1 plus 2.1 plus 2. Okay, we have to deal with what's in the parentheses first because of PEMDAS. So I'm going to underline that section. 2.1 plus 2 gives us 4.1. Okay, now we bring down that 1, and now we add on the next round. So 1 plus 4.1 gives us 5.1. So if you notice, those Shania, or I'm sorry, I'm used to saying Shania. Chanel's answer gives us, or Chanel's expression gives us an answer of 4.1. James's expression gives us an answer of 5.1. Let's see what Christian's gives us, and then we're going to have to go back and check Miss Peterson's expression. So let's plug in 1 for x and 2 for w. Okay, we have 2 multiplication problems, so we want to start in order from left to right. So we have 2.1 times 2, 2.1 times 1, which gives us just 2.1. Now we bring down that 2. Okay, now we multiply this round. 2.1 times 2 gives us an answer of 4.2. So again, a different value. So let's come back up and solve Miss Peterson's. We're going to use the same values for each of our variables, but we're going to solve Miss Peterson's. So we have x represents 1 plus 2.1 plus W equals 2. So we must start with what's inside the parentheses. 1 plus 2.1 gives us 3.1. And now we have to add 2. 3.1 plus 2 gives us an answer of 5.1. So whose answer does that match below? Chanel's, James, or Christian? Well, it matches James. They both got an answer of 5.1. So all we have left to do is write an answer statement. James, and I'm going to say what property was applied here. Now this involved grouping. If you look at Miss Peterson's original expression and you look at James's original expression, the grouping is the only thing that's different. In Miss Peterson's, they group X and 2.1, and in James, they group 2.1 and W. So James is using the associative property. So James applied the associative property, and since we're working with addition here, it's the associative property of addition. To write an equivalent expression. So let's look at our conjecture again. It said algebraic expressions are equivalent if they can be evaluated to the same value. In both cases, test the conjecture 1 and test the conjecture 2, we came up with equivalent values between the two different expressions. Okay, so our conjecture ends up being true. All right, guys.